Now, for this example, we're going to prove the property of midpoints using a two-column proof as well. If we know M is the midpoint of AB, we're going to prove that AB is 2 times AM and AM is 1/2 AB. So we've got this picture, and this is what we're trying to prove. When we do a problem like this, if it says M is the midpoint of AB, we want to know, where do we go from here? Well, the best thing for you to do is to mark the figure based on what's given, not based on what you're trying to prove, but what's given. If M is the midpoint, we know that these two are equal, so mark that. That is another statement that you can make. You can make the statement AM is equal to MB, or AM is congruent to MB, because of the definition of what midpoint is. We use definitions whenever they give us a word that we can use. So when we go from the word to what it means, or what it means to the word, we're using a definition. We're going to take a look at what this looks like in terms of a proof. So we're going to prove AB is equal to 2 times AM. We're also going to prove that AM is equal to 1/2 AB, which should be easy once we prove the first thing. So we start off again with AM being the midpoint of AB, and we mark the figure. Make sure you always mark the figure with what's given. Not with what you're trying to prove, but what's given. So, of course, M is the midpoint of AB because it's given to us. Our next step is to write that AM and MB are congruent. That's what we got from marking the figure. And again, we go from the name of something to what it means, so that's a definition of midpoint. Now, a very important definition we use also is whenever we go from congruence to equality or equality to congruence. Whenever we want to use equals, it's because we need to work with equations. You cannot add or subtract things when it's congruence. We can only do it when it's equality. So we change this to equality. Depending on whether we have angles or segments, whenever we change from congruence to equality or equality to congruence, we call that the definition of congruent, in this case, segments. If it was angles, we'd say the definition of congruent angles. But in this case, the definition of congruent segments. Now that we have this, the next step is for us to use the segment addition postulate. We know the whole thing is AB, and that's equal to AM plus MB. So that would be the segment addition postulate. Since we have AM and MB equal, and we know AM plus MB is equal to AB, we can substitute in AM where we see MB. And since we want AB to be equal to 2AM, we're going to substitute MB and replace it with AM. Now we have AM plus AM is equal to AB. And again, that was the substitution property. The next step, we're finally getting to the point where we can prove part A of this. If we add those two together, we know that 2AM is equal to AB. Now, what's our reason for that? Our reason would be the distributive property, and let me explain why it's the distributive property. When we look at these two, we have AM plus AM. If we were to factor out an AM, we would be left with 1 plus 1 times AM. 1 plus 1 is the same as 2, so we would get 2AM. So what we're doing whenever we combine like terms, what we're really doing is using the distributive property. So this is the same as this, which is the same as this. So when we go from here to here, that's distributive property. Now we want also that AM is equal to 1/2 AB. In order to do that, we'd have to either multiply both sides by 1/2 or divide both sides by 2. And so we get our answer, and our reason for that is the division property of equality. You could have also multiplied both sides by 1/2 and gotten the same answer. But in either case, we have that. Now, a couple questions about this proof after this. It says, how would things look different if instead of doing AB equals 2 times AM, we do AB equals 2MB and MB equals 1/2 AB? We're going to go back just to see what that would look like. So if we wanted instead, and let me fix this so that we can see it better. If we wanted an MB here and we wanted an MB here, what we'd have to do is When we got to this step right here, instead of replacing MB with AM, we would replace AM with MB. So this would be MB plus MB, and then we'd have 2MB equals AB, and finally we'd have MB equals 1/2 AB. Nothing on the right side would change. We would just replace AM with MB instead of replacing MB with AM. So that answers that question. And again, on steps 5, 6, and 7, AM would replace MB. And that's it for this one. Thank you.